Hi, my name is Mostafa Gomar. I'm a BRU21 PhD candidate in the program area of drilling and well. Briefly, I will present a study on real-time fault and symptoms detection in drilling operations with wire drill pipe. The primary objective of drilling optimization is to drill wells as quickly as possible while considering safety and finalizing operations in the well with a usable completion. Drilling operation can be optimized by identifying downhole drilling problems at the right time so that they can be treated efficiently to reduce downtime to the drilling operations. Among the most famous drilling problems are washout, fluid exchange, which is fluid loss or influxes between the borehole and the formation, and also pack-off. Almost all downhole drilling problems like annular pack-off, bit dynamics, and fluid losses are associated with the change in some measurable parameters such as pressure, temperature, torque, hook load, and vibrations. So the main objective of this study is to develop an algorithm to relate the variation in these parameters to the mentioned drilling problems. With a deeper understanding of the subject, we can see that several factors such as changes in the annular area, variation in fluid density and viscosity, and fluid exchange, and variation in the axial and rotational friction are responsible for the variation of the measurable parameters. This study started with a focus on the bit dynamics to provide a solution to estimate contribution of the bit to the total drill string vibration. We started by developing two equations for the axial and cutting forces. These two equations are assembled based on different parameters. For example, bit design parameters, back rake angle, and the cutter diameter, drilling operation or drilling dynamic parameters like differential pressure at the bottom of the hole, and the cutting area, which is proportional to the rate of penetration, and also wear flat area below the cutters and the cutter wear height. Then micro forces, axial and cutter, which is calculated based on these two equations, are assembled using the concept of equivalent cutter and equivalent blade to estimate the vibration and the dynamic of the bit, and also to provide a solution of the dull condition of the bit under real time. Then measurable parameters like pressure, temperature, vibration, torque on bit, and weight on bit are recorded by ASMs at different points along the borehole. Data are fed into the simulator to estimate rock drillability, provide online dull grading of the bit, and also analysis on the bit and drill string vibration, and also provide estimation of the fluid losses, pack-off, and washouts. Here is an animation of the study performed in an interval drilled in a well on the Norwegian continental shelf. Each data point represents an update of the cutter dull condition during drilling operation. The x-axis represents the cutter wear height that is worn out on the cutters, and this simulation results is for the equivalent cutter number 5, which is located on the nose area of the bit. The other interesting outcome of this study is to estimate changes in rock drillability by plotting a specific energy versus drilling strength. Each set of data with different slopes represents an interval with a specific rock drillability. In addition, this plot provides a qualitative assessment of the cutter dull condition by comparing total energy consumed at cutters, which is Y value at each point, to the true value of the energy required to drill the rock. The difference indicates the amount of energy dissipated by the wear flat area below the cutters. This plot shows variation in a specific energy in equivalent cutter number 5. On the left, you can see an estimation of the torque that is delivered to the bit, to the total torque or the energy that is delivered to the drill string by the top drive system. The difference represents the amount of energy that is dissipated by the friction among the drill string and the borehole valve. Also, on the right, you can see an online assessment of different equivalent cutters from the start of the drilling to the end of the interval. As you see, the cutters on the nose area, which are almost cutter number 5, experience more wear other than cutters like the cutters on the gauge area. The results are comparable to the dull grading condition reported at the field, which is graded 1 and 1 for the inner and outer row of the cutters. Next step in this study is to develop algorithms to predict initiation and progress of drilling problems like annular pack-off and fluid losses by using data acquired by a long string measurement system. And you will hear soon about this part of the research. Thank you for your attention.